Hi, good morning, everyone. My name is Liam. I have a Master's of Science degree in engineering from Texas A&M. Today, I'm going to talk about programmable logic controllers, PLCs. This is going to be beginner and intermediate level. First, we'll talk about the history of a PLC. We'll see what the purpose and function of PLC. We have vendors in different parts of the world supplying automation products, and we'll see the list of vendors. We'll see the configuration architecture of PLC, both external and internal. Based on construction, we can divide PLCs into three. Based on size and capacity, we can also divide PLCs into three. We look at control devices, both inputs and outputs. We look at wiring as well. We have five programming languages that we can use to program PLCs. Of course, the most common one these days is ladder logic. This is going to be a series of training. Today, I'm going to talk about the introduction part. That's part one. And next part is going to be PLC standard wiring, what tools you need for wiring, the most common symbols, and we'll look at the sketches as well. Part three, we'll talk about wiring PLCs. We bring in switches, lights. We'll talk about capacity of a given PLC. Let me say if you have a project and if you know what you want to do, what kind of PLC you need to buy, we'll discuss about that as well. Part four, we are going to talk about connecting PLC with a computer or a laptop. For this project, we'll talk about BAP PLC. It is a new company startup in US, and they have a very cheap and good quality PLCs. Part five, we'll talk about on and off switches, both physical or external and internal switches. When you program a PLC using a ladder logic, usually you might be using a lot of internal switches. That will help you to get your project cost. Part six, we'll talk about programming and wiring traffic lights. All of these projects is going to be a wiring, that's a practical section, and we'll see how we can program that PLC after we wire both the inputs and the outputs as well. So for this traffic light, it's going to be intersection, so we need at least three lights on each direction. So it's going to be 12 lights at least. And the first one, we program it using timers, just based on timing. We'll open one of the line, one direction versus the other. There is another one, another project, the same project. We are going to bring in sensors, and based on the sensor will tell us which of the line has the highest number of cars, and then based on that we can also let one of the direction to go while we put all the red lights on the other directions. Part 7, we'll talk about programming timers. Of course, in part 6 we'll talk about timers, but that's going to be only one type of timers. On part 7, we'll talk about all the timers that we have. Part 8, we'll talk about bringing counters. They're really important in most automations. Part 9, we'll see how we can control the motors. In most of the case, if it's a small motor, first you connect the relay with the PLC, and the PLC is controlling the relay. The relay is controlling the motor, if it is small motor, DC or AC, single phase. However, if you have three-phase motor, usually you connect the relays with the PLC, and that relay will be connected to a contactor. The contactor will be controlling the motor, especially if it is a three-phase or high horsepower motor. It is better to use a contactor. Part 10, we'll talk about input sensor like PNP sensors, limiting switches, and have other type of sensor. We'll talk about them as well. Part 11, we'll see how we can use PLC for home automation. One of the projects we'll be doing in this part is controlling the window shield or curtain using light sensors. Whenever it gets dark, the PLC will help us to automatically close the shield or the curtain. We also bring another type of PLCs for this purpose. Part 12, we'll talk about sorting. I have two conveyor belts. So both non-metallic and metallic objects will come, through the conveyor, and the PLC with the sensor will help us to sort. So the metallic object will go to one of the conveyor line, and then the metallic will go to a different conveyor line as well. Nowadays, you see gates in many community, and in some of those areas, you might see security guard. In some places, you may not have security guard. So we'll use a PLC to control the gate to let some people in, to get some people out. Part 14, we'll talk about water level control. We are going to have two reservoirs. So we'll put a lower limiting switch or level sensor and the upper level sensor. Based on the level sensor, we might need to activate the pump to put some water or activate another solenoid valve to drain out some water to control the level between those two limits. Part 15, we look at the fluid dispensing control using a PLC. When you go to the fast food area, stores, shops, sometimes they ask you, do you want small, medium, or large? And based on the order, they give you a cup. So you take that cup to the fluid dispensing machine. It could be coffee, it could be soft drink. So depending on which button you pressed, small, medium, or large, a certain amount of fluid will drop to your cup. So I already have a food grade pump, and we'll see how we wire that, on our PLC. And then, based on which selection you made, it will help you to drop a certain amount of fluid. So this project, again, is going to be practical, wiring plus the programming part. Part 16, we look at how we can wire HMI into our PLC. HMI is a human machine interface. That's what you see in most of the production line. So you have a graphical interface that helps you to communicate with your PLC. They make it very easy, and it will show you the status of different processes. It makes the whole process easy, the control easy. In most of the case, if you have a control or process control engineer, they might have HMI in their office, and they might be controlling a lot of processes using SCADA system and so on. So we'll see how we can wire that HMI, and then after we wire, we talk about how we can put a graphical interface into that HMI. So the history of PLC. PLC, as you know, it's a programmable logic controller. In the old days, some people used to call it standard machine control. Some people used to call it PC, but that is very confusing with our personal computer. So nowadays, it is very common, to say PLC instead of other names. PLC was invented in 1968. It was invented first by a company called Modicon. Richard Morley used to work for Modicon. He is considered as a father of modern PLC in most of the books. So he's a very smart guy, the one you see on the right side. Unfortunately, he passed away before, I think, a few years. Very smart guy. He used to be a director of SME organization. He got a lot of rewards, including from Boeing, because he contributed a lot for automation industry. Before 1968, wherever you go for automation, most factories, they were using relay logic boards, using relays and so many timers as well. For example, in the railroad crossing, many people were killed because there was no early warning system. If you don't know whether the train is coming, you might try to cross, and that train might kill so many people. Nowadays, the early warning system is very good because of the PLC. In general, you find PLC in almost all automation industries, automation machines, PLC controlling different things. It could be, controlling the lighting system. It could be controlling, different processes. Anyways, almost everywhere you go, behind the automation, you'll find PLC. So PLC, it has a microprocessor similar to our personal computer, and it helps you to control different functions. Different functions in the machinery, it could be in the production system, generally in automation industry. In 1982, there was a PLC with I/O up to 8,192 I/Os. That was a lot of inputs and outputs. Many people give different definitions to PLCs. The one from NEMA, that's the National Electrical Manufacturing Association, they called a PLC a digitally operating electronic apparatus which use a programmable memory for internal storage of instructions or internal storage of ladder logic programs, or it could be different kind of programs as well. And then by implementing that, it helps you to do specific functions such as logic sequencing, timing, counting, arithmetic control. It could be adding, addition or subtraction through digital or analog inputs and output modules. That will help you to control various type of machines and processes. This was the letter GM gave to different vendors. GM in 1968, that was in June 6. So what they said is, we want a company or a contractor who can take a project from us and manufacture. During that time, they called it standard machine controller. Nowadays, we call it PLCs, programmable logic controllers. So they said, we want that to work, and the purpose of that PLC or standard machine control is this and that. That's what they describe. And finally, a company called Modicon, that's Modular Digital Controller, took that project and they produced the first PLC for GM. So GM was the first company who got a PLC, not Ford, not Japanese, not Chinese, not European. It was GM in US. So what's the purpose of the PLC? Well, the first is to replace relay logic board, because that was very time consuming. The wiring of different relays, timers was very time consuming. The other thing is, PLC is more flexible. You don't need to do any wiring between inputs and outputs because everything is wired in the PLC. So whenever you want to change the sequence, you might need to change the program, as well as you might need to add or subtract or disconnect some of the inputs. You might need to add more outputs or disconnect some of the outputs. So it's very easy and very flexible. Since you don't have a lot of wiring, the cost of the PLC is also low. It has fast response time and easier to troubleshoot because, as I said, the wiring is not there, that complex wiring, so it's easier to troubleshoot. It needs to have large quantities of contacts. Yes, of course, it has a lot of inputs and outputs. As we said before, the biggest or the largest PLC we have on the market has I/O 8,192. That's a lot. Some PLC has a visual light indication. It will tell you whether there is some issue, error in the PLC program, or if it's running smoothly. When it's running smoothly, it might show you green lights. When it's not running smoothly, it might show you red light. Some of the PLC, like BAP PLC, you have indication light for each of the inputs and each of the outputs. So it will show you whether that input and output is energized or de-energized. And the PLC, in most cases, it use for nowadays, it use ladder logic or BOLAN programming methods. BOLAN is like AND and OR, anode, and so on. And it has to be reliable, maintainable, and short implementation time as well. Well, to give you an example, before the PLC came to the market, the automation industry, whenever they want to change their production line to manufacture a different model of the car, they need to do all the rewiring between the input and output devices, the relays and timers. Some of them that took them 6 months, some even over a year, some at least 3 months. So it was very difficult, and they had to lay off employees. And after 1 year, after they finished the rewiring, they hired people back. So it was really a headache. But now we don't need to do any wiring between the input and output. Everything is done in the PLC. So generally, in 1968, GM said they want the PLC to do the following, and this one is very similar to what we have as a purpose. Say easy to program, yes it is. No need rewiring, control system, no need rewiring. The control system, if you change it, just what you need to change is just change the program. Small in size, cheaper, and high reliability. Simple construction, low maintenance, and price should be competitive, but it is very cheap. Just to give you an example, in terms of price, when I was in school, our professor gave us a project. So he divided the students into two. So for our group, he told us use PLC and sensors, inputs and outputs. And he said for the other group, he said use relays and timers, just a relay logic board. To your surprise, our group finished the project within, I don't know, maybe 2 weeks. And the relay group took them more than a month. And it cost them a lot of money. Our cost was probably 25% of what the relay group paid for that system. And the system also takes a lot of space. Our system takes in a very small place, and we implemented a short period of time. And then after we finish, we were able to do, both group were able to do the same thing. Those relay boards, relays and timers, and in our case, a PLC and with sensors. And then he told us, okay, change, the system that you have to do this. And we were able to change that in a few minutes, because it was not really a big modification. However, the relay group, it took them at least a week to modify, because they need to rewire everything. So generally, if you have a project that use more than, I would say, 2-3 relays and a couple of timers, forget it. It is better to use a PLC. It is cheaper, very cheaper, especially nowadays. I told you, just check the BAP PLC. They have a very cheap, reliable PLC. In terms of function, PLC can help you to control on and off functions. It could be motor, it could be different output devices. It can also be controlling a sequence of flows. So mainly the core function of PLC, it is allowing you to manage complex process by performing steps in a specific order, often used in manufacturing, manufacturing lines to ensure each stage is completed correctly before it moves to the next step. And the other thing is a feedback control. So PLC can incorporate feedback loops to monitor the result of their actions and make adjustments as needed to ensure the process remains within the desired parameter, within the desired quality of products. So for motion control, some PLC are also used to control the precise movement motors and actuators that will enable features like positioning and speed control in the application like robotics and conveyor systems. So you can use, PLC for different functions. In terms of vendors, we have many vendors, even though we know only a few of them on the market. There are so many of them. The biggest one is Siemens globally. They have a market share in automation about, I would say, 31, 32, 33%. Rockwell is the second one in terms of market share. They have about 22, 23% market share globally. And Mitsubishi, the third one, they have about 14, 15% global market share. And we also have big companies like ABB, Honeywell, Omron, Delta PLC. We also have Schneider. By the way, Schneider acquired Modicon. Modicon, as we said earlier, that's the company who made the first PLC because of Richard Morley. As you see here, I put BAP USA. It's a startup company, US. So they have a PLC. When I compare it, it's comparable, both the look and the quality with Siemens, and it is compatible with GX Works Mitsubishi software. So you can either use the Mitsubishi software if you already have that, or they also they have their own PLC software as well. Just contact them. If you email them, they'll give you cheap price, especially if you're buying a lot of PLC. Believe me or not, for 8IO, the new one, that might give you only $50. So nobody beat this price. Believe me, I tried it. Nobody beat this price with this quality. When you look at the internal architecture of PLC, what you have is a input module, output module, and you have central processing unit. We also have memory to store your programs. So in the input module, you can connect push buttons, start, normally open, normally closed. This could be start button, this could be stop button. You can have limiting switch and so on. On the output module side, you can connect output devices. It could be motors, it could be lamps, it could be solenoid valve, and so on. So depending on what kind of PLC you're using, you might need to supply power to the module. Some of the PLC, they have a converter built in. Some of them, they don't have converter. So you might need to supply 24 volt. Of course, there are also PLC that use 110, 220 volt AC, but most people, for safety reason, they don't really use them. Just a simpler version of the architecture. You have central control units. On one side, you have input module where you connect input sensors. You have output module where you connect actuators. A more complicated one as compared to the one I showed you. In terms of memory, you can split that into ROM, RAM, and so on. And I would say, the connection, the address bus, the Ethernet, or the communication is also mentioned here as well. The data bus, the address bus, I/O system bus, and so on. But as you see, the first one we discussed is easier one, and it makes more sense for us. The input is here. It's showing what kind of stuff we can use as an input. It will show output. So I like this one better. So when you look at PLC, the external look, It needs to have different features. Most of the time, the inputs are connected to the top part and the outputs are connected to the bottom part. And you are putting the PLC, the back is going to be like this, mounted to DIN rail. Sometimes people mount it using that, using holes and screws. But most of the time, if you have a control panel, most people, they prefer to put it in DIN rail. In terms of construction, you can divide PLC into three. The first one is micro or compact PLC, that's a small one. The second one is modular, where you can extend it, using extension module. The third one is a plug-in card, where you can plug in different card to extend the capability of that PLC. So in terms of micro or compact PLC, you can have some PLC where you have a display and you have buttons to change some of the input parameters or values. And the rest are, just you can program those PLCs using a software and then load that program, the ladder logic program, into that PLC. One of the PLCs that I'm going to show you, the one you see on the right side, this is the one I mentioned. This is from BAP PLC. It's a startup company. It's really a very good quality PLC. If you have a project, just buy and test it. You'll be happy with the quality and the price. So in terms of modular, you have a PLC and then you have racks where you can add different extension modules to extend the capability or capacity of the PLC. So you can add extension modules. The third one is plug-in card type. So you have, let me say, a PLC where if you want to add cards to extend the capability, you can do that. And then, you add those cards. But bear in mind, it's not all PLC taking the card. There are specific type of PLCs where you can add cards to extend the capability. So in terms of capacity, the size of IOs, you can subdivide or divide PLC into three. The first one is small PLC, where you can have up to 128 IOs, inputs and outputs, and the memory up to 2 kilobytes. And this type of PLCs are mainly for simple to advanced level control. The second PLC that you have is medium. You can have a IO up to 2048 inputs and outputs, and the memory up to 32 kilobytes. The biggest one, or the large PLC, it is way more sophisticated, and you can use that to control the entire plant. It could be uranium plant, it could be chemical processing plant, and so on. And this type of PLC can have IO up to 8,192, and the memory is up to 750 kilobytes as well. Even though this type of PLC give you, so many IOs, do you want to process, control the entire plant using one PLC? Probably not, because what happened is if something happened to the PLC, the entire plant will shut down. So instead of doing that, most companies, what they do, or what I suggest is, let me say if you have a process, maybe for that particular process, use one PLC. For another process, use one PLC. If something happened to that process may not function, and the other process is still running. However, if you use just one PLC and control systems for the entire plant, bear in mind, everything might shut down one day. So that will cost you a lot of money and time as well. In terms of input device, you can use push buttons. It could be start button or stop buttons. You can use limiting switch. You can use thumb wheels. You can use level switches. You can use flow meter, flow switch. For output device, you can use motors, and depending on what kind of motors you have, small, big, three-phase, single-phase, DC, AC, you can use relays and or contactors to control that motor. You can also use a solenoid valve. You can use a LED display as an output as well, especially if you have analog output where it gives you different voltage or different milliampere. You can, based on the value it generates, you can display those values in the LED display. Not the value, but what that value actually representing. You can also use heater or coil as an output. You can use lamps, lights as an output as well. Here is a very simple diagram, wiring diagram, showing you how you can actually wire a BAP PLC. As I told you, I love this PLC because they are very cheap and the quality is, I found it's good, very good. And you can use GXWorks to program this PLC. And the company also can give you their own software. So, as you see, you have power coming from the wall outlet. If you are in US, the power might be 120 voltage AC or 110 in that range. So you connect the line, you connect the neutral, and you connect the ground to the converter. And this converter will convert it to 24 volt plus and minus. You connect the 24 volt to one side of a push buttons. These are the push buttons. And the other side of the push button will be connected, and you input that into the PLC. Since the power is flowing from the converter to the push buttons and from the push buttons to the PLC, so you consider this sinking inputs, sinking because the power is sinking into the PLC. For the output side, 24 volt comes to the lights, one side of the lamp, and the same 24 volt comes to one side of the lamps, and the other side is connected to the output of the PLC. Since the power is coming to the lamps and going out and sinking into the PLC, you call this output sinking output. So BAP PLC, both the input and output are sinking. If you want to control AC motor, this AC motor is single phase. So you connect one of the line to the power outlet. So you connect the line to the motor, and then you have the neutral. The neutral is connected to the relays, one of the terminal of the relays, and the other terminal goes into the wall. Bear in mind, if this is a house wall, most of the time you have a control panel where different power outlets, they have breakers there that will help you to control. Whenever the AC, the amperage is higher, that breaker, the fuse might burn and you might need to change. It might tip over. And the relay is the same thing as the bulbs. So you have 24 volt coming to the coil part of the relay, and there is in the coil you have plus and minus, so you connect this one to the plus side, and the negative side, or it's connected to the output of the relay. Because of that, as we said, this is called sinking output. In terms of programming language, there are 5 programming languages that people use to program PLCs. It doesn't mean you can program any PLC using any of these software. It doesn't mean. Most of the time these days, the most common programming language is ladder diagram. However, some old PLC, they might use sequential function charts. Some of them might use function block diagram. It's graphical. Some of them might use structured text. It is programming. Some might use instruction lists. This is also programming. But bear in mind, the most common one these days is ladder diagram. I use TIA from Siemens. I use RX Logics from Allen Bradley. I use GXWorks 2 from Mitsubishi. All of them use a ladder logic, and very similar in terms of programming. If you understand one, switching to another one is very easy. So in terms of ladder diagram, the old one looks like this. So you have inputs, and they put it as normally open push button icon. And you have the output, it is like a coil. So you have input here on the second rung, it is like normally closed push button. It might be stop button, this might be start button. And the same thing, the coil, on the output you have a coil. This is the traditional, the old ways. But nowadays, if you look at all those three, Kia from Siemens, RS Logics from Rockwell, GX Works 2 from Mitsubishi, they use this like this. It's very similar. So you have normally open. This could be limiting switch. This could be push button. This could be flow meter, and so on. So it doesn't really matter. Whatever type you have a similar input. Normally open, normally closed. And the output coil, most of them, they use a kind of parenthesis. So that's like a coil or the output. In terms of sequential function chart, it is a kind of based on the condition. When this condition meets, you do this action. When this condition meets, you do this action. It is more of graphical. The function block diagram, this is also graphical, but the structure is a little bit different from sequential function chart. The structure text, it is a program. It is like if condition. If the input sensor is like that, then the output is true, or activate, else false. The same thing, instructional list, it is very similar to the structured text, and this is a programming or coding. So I use this list of materials for this presentation, and thank you very much. I really appreciate. If you like this presentation, please click on the thumb. Bear in mind, this is very long presentation. I hope you find something useful. The rest of the presentation will be easier and quicker. And as I said, this is a practical. So first we look at the wiring for those projects, part 2 all the way to 17. First we'll look at the wiring, and then we'll talk about the programming. So it's going to be interesting. They're going to be shorter. They are not going to be long like this one. So if you want to practice, I suggest you to go to this website, email them. They will sell you a PLC, very cheap PLC, good model, good quality. I love them. So, you can contact them through, they also have Gmail. They also have a phone that you can call them. Thank you.